Today you'll be doing 5.2 solving literal equations. At the end of this lesson you will be able to solve literal equations. What it means is you will be getting a new equation for your answer. You will literally be moving the variables around. To solve literal equations, first step is to determine what variable you are solving for. You will circle the variable you are solving for. Do not touch that variable until the very end. And finally, you want to use opposite operations or inverse operations to isolate the variable. I have two problems here. One with integers and one with fractions. I'll start with the fractions. The example asked me to solve for y. So I have 3x plus 2y equals negative 6. I'm going to circle the y that I want to solve for. That should be the last thing I touch. So I'm going to use my inverse operations to isolate the y. First thing I want to do is minus 3x. Minus 3x. So 2y equals negative 3x minus 6. I am literally just moving the 3x to the other side. You aren't really doing any combining of like terms or simplifying. Circle my y because that's what I'm solving for, so it's the last thing I touch. So in order to isolate 2y, I'm going to divide by 2. And when I divide by 2, I divide by 2 on every single integer in the problem. Y equals, I have solved for y, and then I look to reduce the right-hand side. Negative 3 over 2 does not reduce, so it just gets the x, but 6 over 2 does reduce to be minus 3. I've gone from 3x plus 2y equals negative 6 into what looks like a y equals mx plus b, a slope-intercept equation. Y equals negative 3 over 2x minus 3. The other example looks like what we ended with in 5.1. We have fractions. So my first step is to clear the fraction. What I notice is that 3 and 4 do not go into each other. But I can find a least common multiple of 3 and 4, which is 12. 3 goes into 12 and 4 goes into 12. So in order to clear the fraction, I'm going to multiply every part of the equation by 12. (24 over 3x) minus 36 over 4y equals negative 60. And multiply the 12 to every part of the equation. Now that I've done my multiplication, I can reduce so that I eliminate the fraction. 24 over 3 becomes 8x minus 36 over 4 becomes 9y, which equals negative 60. I circle my y because that's what I'm solving for. And I'm going to subtract 8x from both sides. Literally just moving it to the other side. Negative 9y equals negative 8x minus 60. I still don't want to touch the y, but I can divide by negative 9 on both sides, dividing everything on the right-hand side by negative 9, so that I get y equals, I have solved for y. 8 and 9 don't reduce. The only thing that happens is it becomes positive, so I get 8 over 9x. It's going to be plus. 60 doesn't divide evenly by 9, but I can reduce both numbers by 3 to get 20 over 3. Once again, changing it into a slope-intercept equation. 2/3 x minus 3/4 y equals negative 5. was solved to be y equals 8/9 plus 20/3. A new equation for both answers. You will not be getting a number answer on these. You will be getting a new equation. Now we're going to look at the types of formulas you'll see next year in geometry. You'll see a lot more letters than you will numbers. But still, we are literally just going to be moving things to the opposite side. In the first problem, it says A equals LW, and I need to solve for L. So I'm going to circle L. A equals L times W is what I'm looking at. So then the inverse operation for multiplication is division. So I'm going to divide by W on both sides, which is literally just moving it to the other side, so that I get A over W equals L. There's my final answer. A new equation, not a numerical answer, but a new equation. The second equation says A equals 1/2 BH, where it's representing multiplication 1/2 times B times H. I'm solving for the variable H, so I don't want to touch it. First thing I can do is clear my fraction by multiplying by 2. So that I get 2A equals, well, 2 times 1/2 is 2/2, and I don't touch the B or the H. It's only the 1/2 that gets multiplied by 2 because it is a multiplication problem. Now I can reduce my fraction. 2A equals B times H, because the 2/2 reduces. I still want to solve for H, so I circle it. And I'm going to divide by B on both sides, because the opposite of multiplication, or the inverse of multiplication, is division. And I'm literally just moving the B to the other side for an answer of 2A over B equals H. A new equation, not a numerical answer. So the third example, solving for a formula, y equals mx minus 5 for x. It's not a geometry formula, but it is a literal equation, so we're just going to literally move things around. Circle the x because we don't want to touch it. So I can do the inverse of minus 5, which is plus 5 to both sides. So y plus 5 equals mx, which means m times x, it's multiplication. Still trying to solve for x, so I don't want to touch it. So to isolate it, I'm going to divide by m on both sides, divide by m on both sides. So my answer is y plus 5 over m equals x. Or I can rewrite it where each of the variables on the left would be divided by m. Y over m plus 5 over m equals x. Either answer is true. They both show the left side being divided by m. Once again, it's not a numerical answer, but a new equation. Next example, 3c plus 2d equals c. I need to solve for d. What I notice about this one is I have c's on both sides. So whenever I move the 3c over, using subtraction, 2d is going to equal, well, c minus 3c is negative 2c. To isolate the variable d, divide by 2, so that d is going to equal, well, negative 2 divided by 2 is negative 1c. A new equation, not a numerical answer. And finally, we're back to some geometry. You'll see these next year. In the first one, A equals 1/2 times H times the quantity B1 plus B2. We're going to solve for B1. I see that fraction that I want to clear. So I'm going to multiply everything by 2. So 2 times A, and the 2 only gets distributed into the 1/2. You only have to multiply by one thing here, and the 1/2 is what you're trying to clear. I now have 2A equals 2 over 2 times H times the quantity B1 plus B2. Remember, you never distribute into the parentheses whenever you are clearing a fraction. But I now can reduce. The 2 over 2 becomes 1, so I have 2A equals H times B1 plus B2. In 5.1, I would have distributed now. I still want to stay away from distributing, though. I don't want to distribute in and make my problem any harder. So instead of distributing is multiplication, I'm going to do the inverse operation of that and divide by H on both sides. So the opposite of multiplication is division. So I divide by H on both sides to cancel it out there. 2A over H equals B1 plus B2. Remembering that I'm going to get a new equation, not a number answer. I am literally just moving the variables around. So now I want to get B1 by itself because that's what I'm solving for. So subtract B2, subtract B2. So that my answer is 2A over H minus B2 equals B1. A new equation, not a number answer. And the last example, V equals pi r squared times H. Pi is not a variable, pi is a number, so we're going to treat it like a number. We will never be solving for pi, but we are solving for H, so I circle the H. So that I have V equals pi times r to the second power times H. I want to do the inverse operation of multiplication, which is division, and seeing how all of this is multiplication, and that's the part I want to move over to the other side, I'm going to divide by pi r squared on both sides. Canceling it out here, so that V over pi r squared equals H, and it is a new equation, not a number answer. So in solving for little equations, I hope you remember, you will not be getting a number answer. You will be literally just moving the variables around to get a new equation.